We are going to start now the second lecture of chapter 3, class 11th mathematics, trigonometric functions. In this lecture we will talk about the basic definitions and some results related to trigonometric functions, or these are also called the circular functions. So first we look at the definition over here. So let us consider the two coordinate axes. This is our x-axis and this is our y-axis. We have drawn a circle whose radius is 1 unit by taking O as the center. This is the circle we are talking about. This is the circle we have drawn by taking O as the center and radius is equal to 1 unit. Now the point where this circle it intersects with the axis, these points, these are A, B, A dash and B dash. We consider any point P on this circle, this point we are talking about, and this point is such that the length of this arc AP it is theta. The length of this arc AP is theta. Now if this arc length AP is theta, then the angle AOP, that will be equal to the arc length, we are talking about the arc length AB divided by the radius. Arc length we have taken, it is equal to theta, and radius we have taken is equal to 1. So we are saying this angle AOP, this angle is equal to theta radians. Now corresponding to this we have defined the trigonometric or six circular functions, and these are shown on our next slide. So we are saying what functions we can define. First is we have considered this length OM. This length is equal to x. We have drawn the perpendicular from this point P on the x-axis. This length we are saying it is y. So basically this length we are saying this is y, because the coordinates of the point P, they are x comma y. So the first function we are saying x is equal to, we have defined this is equal to cos theta. Second we have y is equal to sin theta. This is just the definition we are talking about, that how the circular functions are defined. It is cos theta is equal to x, sin theta is equal to y. Similarly secant theta is equal to 1 by x for x not equal to 0. So secant theta is 1 by y for y not equal to 0. These are the functions that we can define from here. The next function we will have, it is tan theta and cot theta. So we have tan theta is equal to y by x and cot theta is equal to x by y. Now it is important to note over here that we are not just talking about, earlier in your previous class you have studied that we have a right angled triangle. This angle is theta. This is the perpendicular. This is the base and this is the hypotenuse. We are writing it is ABC, and this triangle it is right angled triangle. Then we have defined sin theta is equal to, it is perpendicular over hypotenuse. Cos theta is equal to base over hypotenuse. Likewise we have defined all the trigonometric ratios, but now we are not talking about these values over here. In these cases we are particularly restricted that this angle, this can lie between 0 degree and 90 degree, and we have defined the value of sin 0, then sin 90 for theta is equal to 90 and theta is equal to 0. We have separately defined the values of all these trigonometric ratios. Now we are talking about, suppose I am drawing this figure over here, and this point P that we have considered, suppose this point P it is lying over here. This is the point x comma y we are talking about. Then the angle that is formed over here, this angle we are saying, this can have up to this point the angle, this angle we are saying over here, the value of this angle is greater than 180 degree, or we are writing it is greater than pi radians. We are not restricted to these values over here, that is the value of theta lies between 0 and 90 degree. It can take any real number. So these are the definitions of these functions corresponding to this angle theta. We are saying what is the value of cos of theta in this case? That will be equal to the value of x. Whatever the value of x is, that is the value of cos theta. Whatever the value of, I am talking about this angle over here, this angle is theta. I am talking about sin theta, that will be equal to y. Whatever the value of y is there, we will get that is the value of that will have value sin theta. So how we are going to find that value? We draw these two lines over here. This value of x, this is the value of x we will have, and this is the value of y we will have, and we can see that both these values, these will be negative values. These things will be more clear to you on our next slide, that what we are trying to say. But at this moment you can see the difference between what you have studied earlier and what we are studying now. Earlier we have studied the trigonometric ratios. We are saying the value of theta was lying between 0 and 90 degree, and for 90, theta is equal to 90 and theta is equal to 0, separate definition was given to us. Now we are talking about the trigonometric functions. These are the definitions of the trigonometric functions or the circular functions. Next we have to prove the three trigonometric identities, and these identities you are already familiar with. First is cos square theta plus sin square theta is equal to 1. Second is 1 plus tan square theta is equal to secant square theta. And third is 1 plus cot square theta is equal to cosecant square theta. These three identities we have to prove. So their proof, we already know that it is similar proof that we have already done in our previous classes for the trigonometric ratios. But the only difference is over there we were considering that angle corresponding to that particular right angle to triangle. Now we are talking about the circular functions. So again we have considered this is our x-axis, this is our y-axis. We have drawn a circle of unit radius. This point P is there and its coordinates are x comma y. The radius of this circle, it is 1 unit. Now if we look at this triangle over here, we are talking about this particular triangle over here, we will have x square plus y square, that is equal to 1, and we know that x square is equal to cos square theta. This is by the definition of the function we have defined, that is cos theta is equal to x, and y square is equal to sin square theta, and we obtain that this is equal to 1. Now if we divide this whole equation with both sides with cos square theta, the answer we obtain it is 1 plus tan square theta is equal to secant square theta. If we divide this equation with secant square theta on both sides, with sin square theta, not secant square theta, with the sin square theta on both sides, the identity we obtain it is cot square theta plus 1 is equal to cosecant square theta. So these are the three identities that we have. First is cos square theta plus sin square theta is equal to 1. Second is 1 plus tan square theta is equal to secant square theta. And third is 1 plus cot square theta is equal to cosecant square theta. Next is the definition of negative arc length. So we are saying if we are given a circle, suppose this is the initial point from which we start moving on this circle, and we are moving on this circle in the anti-clockwise direction. We are moving in this direction. Then we measure the arc length as positive. That is, if suppose it has something has started from this point A and reached the point B and it has moved in this direction, then we say that the arc length, say it is L. Suppose this someone has moved from this point A to this point C and it has moved in this direction, the length we have over here it is minus L. So this minus sign over here, it just tells us that the object that is moving in the clockwise direction. So this is how we are talking about the negative arc lengths. Next we have is to prove that for any acute angle theta, First thing we have to prove is that cos of minus theta is equal to cos theta. Now look at this value over here, it is cos of minus theta we are talking about. If suppose these are our axis, this is our x-axis, this is the y-axis, we are talking about an angle theta over here. This is some point P is there. So this is the angle theta we are saying. Then the angle minus theta means that we are moving in the anti-clockwise direction. Then the angle minus theta means we are moving in the clockwise direction. So we are talking about basically 2 points. One is this point P is x, y is there, corresponding to which the angle is theta. Now we have the point over here. We are saying we have moved this in the anti-clockwise direction. We have moved this point in the anti-clockwise direction, and the coordinates of this point will be P of x comma minus y. This point we are saying this point will be x, corresponding to this point will be y, corresponding to this point will be minus y. So what we get is, if we are talking about the function corresponding to this, what we get, the angle over here it is theta. We are talking about the point pxy, the angle over here it is theta. So what we get is x is equal to sin theta cos theta, corresponding to this value. X is equal to cos of minus theta. I am talking about these points over here. This point is x, and we know x is equal to cos of theta. Theta is this angle over here. When we are talking about this point over here, this x is equal to cos of minus theta, because the angle over here it is minus of theta. So what we get from this is that cos of minus theta is equal to cos of theta. Similarly, if we look at the value of y over here, this y is sin theta, and this minus y over here, this will be minus sin of minus theta. These values we are saying. So what we get is, when we are talking about these values over here, we get y is equal to sin theta, and the second value we are obtaining it is minus y is equal to sin of minus theta. So equating both these values, we obtain that sin of theta, that is equal to minus sin of minus theta. First we are getting it is cos theta is equal to cos of minus theta. Second we are obtaining it is sin of theta is equal to minus sin of minus theta. Now if we divide both these values, the answer we obtain it is tan theta is equal to minus sin of minus theta over cos of minus theta. So that is equal to minus tan of theta minus theta. This thing is our third result. We are saying tan of minus theta is equal to minus of tan theta. We can write it like tan of minus theta is equal to minus of tan theta. Next, if we want to calculate the value of cot theta, the answer we will have it is cos of minus theta over minus sin of minus theta. The answer we obtain, that is equal to minus cot of minus theta. So the result we are writing over here, we get, that is cot of minus theta is equal to minus of cot theta. Now corresponding to this first result, we will get secant of minus theta is equal to secant theta, and cosecant of minus theta is equal to cosecant theta. This thing basically gives us that we are talking about when this function cos of minus theta, we are writing, suppose f of theta that is equal to cos theta, f of minus theta is equal to cos of minus theta. What we get is f of theta is equal to f of minus theta. So what we mean to say from this is that cos theta is an even function. Similarly, this result gives us, the second result gives us sin of minus theta is equal to minus sin theta, means sin is an odd function. So these are the results corresponding to these negative arc length. Next are the signs of trigonometric functions in various quadrants. So if we look at various quadrants over here, we are saying we have drawn a circle. We are considering the point P on the circle, and that circle may that point may lie in different quadrants. Suppose we are talking about a point P that lies in the first quadrant, then the values of both x and y will be positive. If the point P it lies in this quadrant, the value of x will be negative, y will be positive. If the value of P lies in this quadrant, both the values of x and y are negative. If the point P lies in this quadrant, the value of x is positive and the value of y will be negative. Now what is this x? This is basically cos theta, this is sin theta. It means cos theta is positive, sin theta is positive. If both sin and cos are positive, then tan theta is also positive, secant theta is positive, and cosecant theta is positive. And this thing we are writing as, in the first quadrant we have all the trigonometric ratios. They are trigonometric ratio, not, we are not using the word ratio, we are saying all trigonometric functions, they are positive. In the second quadrant we have this value is cos theta, this value is sin theta. So we are saying cos theta is negative, sin theta is positive. On dividing both these values, we will get tan theta is negative, we get secant theta is negative, cosecant theta is positive. So basically we are saying that sin is positive, cos and tan are negative. So only sin is positive. When we are talking about this quadrant, we are saying sin is negative, cos is negative. So division of both these, that is tan theta, will be positive. So we are saying tan is positive and all other they are negative. All other means we are talking about, we are not writing it is all other, it is sin and cos, they are negative. And in the fourth quadrant we will have cos is positive, this is cos theta, this is sin theta. So we are saying cos is positive, tan and sin are negative. So what we get from this is that in the first quadrant all trigonometric functions, they are positive. In the second quadrant sin and cosecant are positive and all other are negative. In the third quadrant we are having sin and cos, both are negative. So tan is positive, so cot is also positive and all other are negative. And in the fourth quadrant cos and secant are positive and all other are negative. Next we have given the table over here corresponding to the trigonometric value of the trigonometric of some particular corresponding to particular angles. And we already know for trigonometric ratios that how we write these values. It is sin theta, cos theta, tan theta we are talking about. Over there we are writing it is 0, 30 degree, 60 degree, 45 degree and 60 degree and 90 degree. We know that these values in radian, it is 0 radian, this is pi by 6 radian, this is pi by 4 radian, this is pi by 3 radians, this is pi by 2 radians. Now corresponding to 0, how we write these values? It is 0, 1, 2, 3 and 4. We divide all these values with 4. Put the square root sign over here and the answers we obtain, it is 0, 1 by 2, 1 by root 2, root 3 by 2 and this is 1. Then the values of cos are 1, root 3 by 2, 1 by square root 2, 1 by 2 and 0. Then we divide these values, we get the answer, it is 0, 1 by root 3, then 1 square root 3 and this value it is not defined. Now suppose we are calculating the value of the angle at pi. The next values we are calculating, they are corresponding to the value pi, then 3 pi by 2, and then 2 pi. The answers we will have, we are talking about these. This is the circle we are talking about. When I am saying I am calculating the value at pi angle, means I am talking about this point over here. This is our point pxy. Now what are the coordinates of xy? The radius of this circle, it is 1 unit. So the coordinate of this point P, they are 1, 0. So the value of cos theta we will have, that is equal to, this is minus 1, 0, not 1, 0, minus 1, 0. So the value of cos we will have, it is minus 1. Value of sine we will have, it is 0. Next we are talking about the angle 3 pi by 2. 3 pi by 2 angle we are talking about over here. This whole angle, this will be the angle 3 pi by 2, and the point corresponding to this angle over here, this point will be, we are saying this, the x coordinate for this point, it is 0, and y coordinate, it is minus 1. So the answers we have, for cos the value, for sine the value, it is minus 1, and for cos the value, it is 0. When we are talking about the angle 2 pi, we are talking about this whole angle over here. This is the angle 2 pi. So 2 pi is basically, we are talking about the angle 0, the values at the angle 0. So we are saying the coordinates of this point, they are 1, 0. So the answer we obtain, this is 1, 0. On dividing these values, we will obtain the values of tan theta. So corresponding to this first value, we will get the answer, it is 0. For the next, it is not defined, and for the last, it is 0. So we have obtained this table over here corresponding to sum of the trigonometric, sum of the angles. We have listed the values of these trigonometric functions, sine theta, cos theta, and tan theta. Next we are saying the domain and range of the 6 trigonometric functions. So first of all, we are looking at this function sin x. How we have defined the sin x? We have considered a circle of unit radius, and we are saying the value, this point P we have, this point is cos theta comma sin theta. Now it is clear from the definition over here that the radius of this circle, it is 1. Now if we are talking about this length, this is the length x, that is equal to cos theta. This is the length y, that is equal to sin theta. Now what is the maximum and minimum value of sin theta and cos theta? We are saying the maximum value cos theta can take, it is equal to 1, and the minimum value cos theta can take, it is equal to minus 1. So we are saying the range of this function sin theta, or the range of this function cos theta, they are minus 1 to 1. And when we are looking at the domain of this function, we are saying this angle, it starts from the value 0. Suppose it has made a rotation, the value, the angle we obtain, it is 2 pi. It has made the second rotation, the angle we obtain, it is 4 pi. If it is moving in the anti-clockwise direction, the angle may be minus 2 pi, minus 4 pi. It means we can substitute any value, any real number as the value of theta. So we are saying the domain of the function sin x, it is r, domain of the function cos x, it is r, and the range corresponding to these values, it is minus 1 to 1 and minus 1 to 1, because the value of this pxy, when we are talking about this x and y, we are saying these are less than equal to, mod of y is also less than equal to 1. Next is tan x. So when we are talking about the function tan x, we are writing it is equal to sin x over cos x. Look at this denominator part over here. We know that the domain of the function will be, the domain of the function tan x, we are saying that will be all real numbers except for those x for which cos x is equal to 0. And we have already seen the points where cos x is 0. The first point we will have, it is pi by 2. The next point we will have it is 3 pi by 2. Similarly, if we substitute the values, minus pi by 2, it will be 0. If we substitute the value minus 3 pi by 2, it will be 0. And likewise, if we continue at all these points, the value of cos x is 0. We are saying from real numbers, we have removed this set. From real numbers, all real numbers, the domain of the function tan x is all real numbers except for those numbers where cos x is equal to 0. And these are the numbers where cos x is equal to 0. And in general, we can write it is equal to r minus, what we can write these terms. These are basically, we are writing 2n plus 1 pi by 2. 2n plus 1. 2n plus 1 means if we substitute n is equal to 1, 0, the value we get it is pi by 2. If we substitute n is equal to minus 1, the value we obtain that is equal to minus pi by 2. So we are saying that the domain of the function tan x, that is all real numbers, we are saying x belongs to R means all real numbers, such that x should not be equal to this except for those numbers which are of this form, that it is minus pi plus minus pi by 2 plus minus 3 pi by 2. All these numbers we are leaving, where n belongs to I is the set of integers. I over here, it represents the set of integers. Similarly, when we are talking about cot x, we are saying cot x will be, the domain of the cot x will be all real numbers except for those numbers x belongs to R for which sin x is equal to 0, and sin x is 0 at the points 0, pi, 2 pi, means R minus 0, plus minus pi, plus minus 2 pi, at all these points it is 0. So these points pi, 2 pi, 3 pi, 4 pi, all these values we are saying it is R minus x belongs to R, such that x is equal to n pi. And this set it is written over here that it is all real numbers except for which x is not is equal to, or except for which x is equal to n pi. And the range of these two functions, they are R. These domain and range, these will be more clear to you when we will look at the graph of these functions. Otherwise, you can see these values as, we are saying the value of tan x we have, that is equal to sin x over cos x. So if we substitute different values of x over here, when we substitute different values of x over here, suppose we are saying that the value of tan we have substituted, or you can just look at the table that we have already written for these values. We are saying the value of tan for 0 we have it is 0, then it is 1 by root 3, then it is 1, then it is square root 3. So basically these values, these are increasing as the angle is increasing. At 0 the value is 0, then the values these are increasing in this way, and it can go up to infinity. So we are saying this thing will be more clear to you when we will talk about the graph of the function tan x. So we leave this discussion at this point. So you can just remember that the range of the function tan and cot, they are R. Next is, we are talking about the function cosecant x. So the domain is all those points where sin x is equal to 0, and when we are talking about secant x, it is domain is all those real number except for the point where tan x cos x is equal to 0. So when we are talking about the domain of tan x and secant x, they are same. The domain of cot x and cosecant x, they are same. And when we are talking about the range of these functions, so it is range of cosecant x, it is r minus 1 to 1, and the range over here it is r minus 1 to 1, because when we are looking at this function secant x, say, so that is equal to 1 by cos x, and cos x can take the values minus 1 to 1 closed interval. It means secant x will take the value all real number except for minus 1 to 1 closed interval. So the answer we obtain it is r minus 1 to 1, this is open interval over here. It can take the value 1, but it cannot take the values between -1 and 1. So we leave this discussion at this point, and we will continue this discussion when we will look at the graph of the trigonometric functions. The next definition we have over here, it is the periodic function. This thing we have already discussed in our lecture related to the even and odd functions. So a function fx is said to be periodic. A given function fx is said to be periodic if there exists a constant real number p such that f of x plus p is equal to fx, and the least positive value of p for which fx is equal to f of x plus p is called the period of the function fx. So for details of these results, you can look at the video related to even and odd functions. Over there we have discussed the definition of periodic functions and examples over there. Next is, if fx is a periodic function with the period p, then f of ax plus b with a greater than 0 has the period b over a. So based upon these definitions, the first result we are going to prove now is that the period of the function sin x and cos x, they are 2 pi. So it is quite easy to see that sine of theta plus 2 pi, that is equal to sine theta. We are saying how these functions are defined, that we are given the coordinate axis, x-axis and y-axis. We have drawn a circle of unit radius. The radius of this circle, it is 1. We consider any point p x or y on this circle, and suppose the angle that it is forming over here, it is theta. Now so if we move this angle or this line we are talking about, if we rotate this line by an amount of 2 pi, we will again reach this point p over here. Now the total angle will become, it is 2 pi plus theta. We have reached this same point. So what we are saying is, now earlier corresponding to this x it was cos theta, corresponding to this y it was sin theta. Now corresponding to this x we have it is cos of theta plus 2 pi, corresponding to this y we have it is sin of theta plus 2 pi. We are writing x is equal to cos theta, that is equal to cos of theta plus 2 pi. We are saying y is equal to sin theta, that is equal to sin of theta plus 2 pi. Similarly, if suppose we make another rotation, over here, we will get over here it is 2 pi plus theta, that is 4 pi plus theta, and these values will be equal to cos of theta plus 4 pi. This will be equal to sin of theta plus 4 pi. Likewise, this will hold for 6 pi, 8 pi and so on, and smallest of all these values it is 2 pi. So we are saying what we have to prove was that sin of theta plus 2 pi is equal to sin theta, cos of theta plus 2 pi is equal to cos theta. So we have obtained this result from this diagram. Now moving on to our next slide, you can say that this 2 pi is the least value. We have seen that cos of theta plus 2 pi, cos of theta plus 4 pi, cos of theta plus 6 pi, so on. All these values, these are equal to each other. If we say the values we have over here, the periods we have, the values of p for which cos of x plus p is equal to cos x, the values of p that we have, it is 2 pi, 4 pi, 6 pi and so on, and the minimum of all these values it is 2 pi. So we are saying that the period of the function sin theta or the period of the function cos theta, it is 2 pi. So the period of the function sin theta or cos theta, it is 2 pi. Similarly, The period for the function secant theta and cosecant theta, that will be 2 pi, and the period for the function tan theta and cot theta, we have these functions each have the period pi. Further, we have the result that a constant function is periodic but it does not have any period. So for the details you can refer to the video related to even odd functions and the periodic functions. So in general, these results can be written as, when we are talking about this particular result, you can write it is cos of theta is equal to cos of theta plus 2n pi, sine of theta is equal to sine of theta plus 2n pi. This thing holds. So these results are mentioned over here, that for any real number theta and for any integer n, we have sine of theta plus 2n pi is equal to sine theta, cos of theta plus 2n pi is equal to cos theta, then tan of theta plus n pi is equal to tan theta. Next we have cot of theta plus n pi is equal to cot theta. Next we have secant of theta plus 2n pi is equal to secant theta, and cosecant of theta plus 2n pi is equal to cosecant theta. So next we solve some problem based upon these results. Now the first question we have is, if secant theta is equal to minus 13 by 12 and this angle theta lies in the second quadrant, this point P is over here and this theta lies in the second quadrant. Now if theta lies in the second quadrant, it means the coordinate of this point will be of the form minus x comma y. What this thing gives us? This thing gives us that cos is negative and sine is positive. Now the value of secant theta we have, that is equal to minus 13 by 12. So this thing gives us cos theta is equal to minus 12 by 13. Now what is the value of tan theta that we will have? That is equal to, we are using the formula, it is tan square theta is equal to secant square theta minus 1. So it is 13 by 12 square minus 1. We are not writing the sign in this case up to this point. So we are saying the answer we obtain, this is for the value of tan square theta. So the answer we obtain, that is equal to 13 square minus 12 square over 12 square, and this comes out to be 25 by 144. So we get that tan theta is equal to plus minus 5 by 12. Now we are talking about the second quadrant, and we know that in second quadrant, except for sine and cosecant, all other trigonometric ratios, they are negative. So we are saying the value of tan theta will be minus 5 by 12. We have the value of cos theta is minus 12 by 13, tan theta is minus 5 by 12. So cot theta, that will be minus 12 by 5. Now we have to calculate the value of sine theta. We know that tan theta is equal to sine theta over cos theta. So sine theta is equal to tan theta into cos theta, that is equal to minus 5 by 12 into minus 12 by 13. So the answer we are left with is 5 by 13, and cosecant theta will be equal to 13 by 5. So what we are seeing over here, that sine is positive, cosecant is positive, tan is negative, cot is negative, and this cos is negative, and secant is negative. So these are the values that we have to calculate. Next is, if sine theta is equal to minus 4 by 5 and pi is less than theta is less than 3 by 2, it means the value, this point P, it lies in the third quadrant, and in third quadrant we know that tan and cot are positive and all other trigonometric ratios, they are negative. Now we are given that sine theta is equal to minus 4 by 5. We have to find all other 5 trigonometric functions. So we are writing it as cosecant theta, that is equal to minus 5 by 4. Now sine square theta plus cos square theta is equal to 1. So we get cos square theta is equal to 1 minus 16 by 25, that is equal to 9 by 25. So the value of cos theta we have, it is plus minus 3 by 5. As the cos, this point is lying in the third quadrant, we get that cos theta is equal to minus 3 by 5. The value of cos theta will be minus 3 by 5. So the value of secant theta will be minus 5 by 3. Next we have to calculate the value of tan theta. So tan theta will be sin theta over cos theta. This is equal to minus 4 by 5 into minus 5 by 3. So the answer we obtain, it is 4 by 3. And the value of cot theta will be 1 over tan theta, that is equal to 1 over 4 by 3. The answer we obtain, that is equal to 3 by 4. So these are the values of cos theta, tan theta, cot theta, secant theta and cosecant theta. Now next we have find the values of the following. It is first is sine of 25 pi by 3. Now if we divide, we can see from here that the first of all we have to find in which quadrant this value is lying. So to find this, we are dividing 25 with 3 and we obtain that the answer we have, this 25 by 3, we can write it is sine of 8 pi plus pi by 3. What this 8 pi means? When we are talking about 8 pi, this is equal to 4 into 2 pi. It means how the angle is calculated. We have started from this is OA. We have given one rotation, then the second rotation, then the third rotation, then the fourth rotation, and after this fourth rotation we are moving an angle of pi by 3. So we are saying that we have made 4 complete rotations and after this we have moved an angle of pi by 3. So this is equal to sine of 2 into 4 pi, or we are writing it is 4 into 2 pi plus pi by 3, and this is equal to sine of pi by 3, and this is equal to root 3 by 2. Next angle we have, it is cos of 41 pi by 4. So if we divide 41 by 4, the answer we obtain, it is 40 and 1. So it means 41 pi by 4, we can write it is 10 pi plus pi by 4. This is equal to 5 into 2 pi plus pi by 4. It means it has made 5 complete rotations. After that we have angle of pi by 4. So the answer will be equal to cos of pi by 4, and that is equal to 1 by square root 2. Next we have it is tan of minus 16 pi by 3. First thing we know is that tan of minus theta is equal to minus tan theta. So this will become minus of tan of 16 pi by 3. If we divide both these values, we are writing 16 divided by 3. So we get it is remainder is 1 over here. So we are writing it is minus tan of 5 pi plus pi by 3. Now look at this value over here, it is 5. It is not an even number. So we can write it is minus tan of 4 pi plus pi by 3. What this 4 pi means? 4 complete rotations. What this pi means? When we are talking about this tan, its period is pi. So this pi is also gone. Now we are in the quadrant. If we look at, we are saying when we look at the quadrant over here, we have made 2 complete rotations. After this we have moved pi. After this we have moved pi by 3. This we have moved pi by 3. So the value of this part over here, this will be positive. So that will be equal to minus tan of pi by 3, and that is equal to minus square root of 3. It is important to note over here, I am again mentioning this thing, that when we are talking about the cos and sine, their period it is 2 pi, and when we are talking about tan, its period is pi. So that is why this n pi is there and this 2n pi is there. Next we have it as cot of 29 pi by 4. So when we are writing 29 divided by 4, the answer we obtain, that is equal to this value 29 pi by 4, we can write it is 7 pi plus pi by 4. So we get this value, this function, that is equal to cot of pi by 4, and cot of pi by 4 is equal to 1. So this is our answer. Now the next part we have it is secant of minus 19 pi by 3. So if we divide 19 and 3, the answer we obtain, this is equal to, first thing we have is secant of minus theta is equal to secant theta. So this question becomes secant of 19 pi by 3. This is equal to secant of 6 pi plus pi by 3. The period of secant it is 2 pi. So this is equal to secant of pi by 3, that is equal to 2. Next is cosecant of minus of 33 pi by 4, and this value will be equal to minus of cosecant of 33 pi by 4. If we divide 33 and 4, we obtain it is, 1 is the remainder, so we get it is minus cosecant of 8 pi plus pi by 4. This is equal to minus cosecant of pi by 4, and this is equal to minus square root of 2. So these are the values that we obtain corresponding to these questions. Now the next question we have to calculate the value of sine of 765 degrees. The values that are given over here, it is in terms of degrees. So first of all, we have converted these degrees to radians, and we know that 180 degree, that is equal to pi radian. So 1 degree, that will be equal to pi by 180 radians, and 765 degrees, that will be equal to pi by 180 into 765, and when we solve these values, we will get it is 17 pi by 4 radians. So our question becomes that it is sine of 17 pi by 4. Now when we divide this 17 and 4, we obtain it is 4 4 the 16, remainder is 1. So we are writing it is sine of 4 pi plus pi by 4. The answer we obtain it is sine of pi by 4, that is equal to 1 by square root of 2. Next is cosecant of minus 1110 degree. Again, pi by 180 into 1110, when we are talking about, the answer we obtain it is 37 pi by 6. So we have to calculate the value of minus cosecant of 37 pi by 6. On dividing these values, we will get this answer as minus cosecant of 6 pi plus pi by 6. This is equal to minus cosecant of pi by 6, and the answer comes out to be minus 2. Now the last part we have it is cot of minus 600 degrees. So now again, when we are talking about cot of minus 600 degree, that will be equal to minus cot of 600 degree. If we convert this 600 to radians, 600 degree to radians, we are multiplying it with 180 by pi radians. The answer we obtain it is 10 pi by 3, that is equal to 3 pi plus pi by 3. So this value, that will be equal to minus cot of 3 pi plus pi by 3. The period of cot function, it is pi. So we are writing this 3 pi is gone, and we are left with is minus cot of pi by 3. So the answer we obtain it is minus 1 by square root 3. Next we have to find the values of these functions. So first is cos of 15 pi. So 15 pi, we can write it is 14 pi plus pi. the period of cos function, it is 2 pi, so we are getting it is equal to cos of pi, and the value of cos of pi we know it is -1 because this value is over here, and the point corresponding to this over here it is -1, 0, so the value of cos we have it is -1. Next is sine of 16 pi, so we are writing it is sine of 8 into 2 pi, this is equal to 0 because we know that sine of 2 pi that is equal to 0, or we are writing it is sine of 0. Next is cos of minus pi. We know that cos of minus pi that is equal to cos pi because cos of minus theta is equal to cos theta, so the answer comes out to be -1. Next is sine of 5 pi, so it is sine of 4 pi plus pi that is equal to sine pi because the period of sine function it is 2 pi, so this 4 pi is basically 2 into 2 pi, so the answer we obtain it is equal to 0. Next is tan of 5 pi by 4, so it is tan of pi plus pi by 4, this is equal to tan of pi by 4, the period of tan function it is pi, so the answer comes out to be 1. Next is secant of 6 pi, so it is 3 into 2 pi plus 0, this is equal to secant of 0 degree, it is not basically degree we are saying, it is 0 radians, so the answer we obtain for this that is equal to 1. Next is we have to prove that sine square pi by 6, we know that the value of sine pi by 6 it is 1 by 2, cos pi by 3 it is 1 by 2, tan pi by 4 it is equal to 1. So when we substitute these values in this formula, we will get it is 1 by 2 square plus 1 by 2 square minus 1, and the answer we obtain that is equal to 1 by 4 plus 1 by 4 minus 1, that is equal to 1 by 2 minus 1 is equal to -1 by 2. So we are saying that LHS that is equal to RHS.